We are now going to look at another method in solving quadratic equations. This method is called completing the square, and it's actually how the quadratic formula is derived. The steps for completing the square are as follows. Isolate the terms with variables on one side of the equation and arrange them in descending order. 2. Make sure the coefficients of x squared is 1. If it is not 1, divide both sides by the leading coefficient. 3. Complete the square by taking half of the coefficient of x and adding its square to both sides of the equation. 4. Express the trinomial as the square of a binomial. Factor the trinomial basically, and simplify the other side. 5. Use the principle of square roots to undo the square on the binomial. And 6. Solve for x by adding or subtracting on both sides. Let's give this a try. In this first example, we have x squared plus 10x plus 9 equals 0. The first step is to isolate the terms with variables, so we'll subtract 9 from both sides. This gives me x squared plus 10x equals negative 9. I left a blank spot here on purpose because I need a third term. I'm going to find that third term by step 2. Take the middle term, which is 10x, take that coefficient, divide it by 2, and get a number. That number you then square. So 10 divided by 2 is 5. Squaring 5, we get 25. And that is the number. So in step 3, it says complete the square by taking half the coefficient of x and adding its square to both sides. So now we're going to add that to both sides. Once we've added it to both sides, we express the trinomial as the square of a binomial. Basically, you're factoring it on the left side because we've now forced it to become a perfect square trinomial. On the right side, we have 16, and on the left, we have x plus 5 times x plus 5. This can be rewritten as x plus 5 raised to the second power is equal to 16. Now we use the principle of square roots to impose a square root on both sides. If it's an even root, we add the plus or minus in front. And that gives us x plus 5 is equal to plus or minus 4. Now we isolate the x and we get x is equal to negative 5 plus or minus 4. This gives me two solutions. X is equal to negative 5 plus 4, and x is equal to negative 5 minus 4. So my two solutions are negative 1 and negative 9. In part B, we have 4x squared plus 8x equals negative 3. This has already had the constant term pulled to the other side of the equal sign. Now I just need to make my leading coefficient 1. So I do that by dividing by 4 all the way across. Now I have x squared plus 2x equals negative 3/4. Now I need to take my coefficient on the x term and divide it by 2, and then take whatever I get and square it. So I am adding 1 to both sides. Now I need to factor the perfect square trinomial on the left, and on the right I need to combine negative 3/4 plus 1. 1 is equal to 4 over 4, so I have 1/4 on the right. My trinomial x squared plus 2x plus 1 factors to x plus 1 and x plus 1. This can also be written as x plus 1 squared, and that's equal to 1/4. Now using the principle of square roots, I can square root both sides. Don't forget your plus or minus on an even root. And this will simplify to x plus 1 is equal to plus or minus 1/2. Now isolating x, I'll have x is equal to -1 plus or minus 1/2. So the two solutions I get are x equals -1 plus 1/2, so -1/2, or x is equal to -1 minus 1/2, or -3/2. In this last exercise, we have 2x squared minus 5x minus 3 equals 0. I'm going to bring the -3 over to the other side. This gives me 2x squared minus 5x is equal to 3. Now I need to divide by the leading coefficient to make the leading coefficient 1. When I do this, I get x squared minus 5/2 x equals 3/2. Now I'm going to take 1/2 of the term that is x, coefficient, so I have -5/2, and I need to get half of that. So instead of dividing by 2, I'm going to multiply by 1/2, which is equivalent. This will give me -5/4. Whatever I get, I then square. So I have 5/4, and it's negative, squared. This will give me 25/16. This I add to both sides of my equation. And this will give me a perfect square trinomial on the left. And on the right, I'll need to build up that first fraction, so it's a 16. That would be an 8/8. So on the right, I have 3 times 8, which is 24/16, plus 25/16, and I can combine those. On the left side, I have x minus 5/4 times x minus 5/4. If you go ahead and FOIL this out, you will see that you do indeed come back with what I started with as the perfect square trinomial. Now I can rewrite this as x minus 5/4 squared equals 49/16. Now I can use the principle of powers to undo the square on the left. Don't forget the plus or minus sign. And I'll have x minus 5/4 is equal to plus or minus 7/4. Now I need to isolate the x, so I'll have x is equal to 5/4 plus or minus 7/4. I can combine these two fractions together and get two solutions. X is equal to 12/4, or when reduced, 3, and x is equal to 5/4 minus 7/4, or -2/4, which is equal to -1/2.